this pencil's broken. Okay. Yeah, that's good. Okay. And we shall go do some music. And this is my talking with the music on. So let's just hear how this sounds on the stream. Did it stop already? Mic test, mic. No, you can't hear it even. Too quiet. I'll turn it up on here. Is this better? Yeah, I think that is. Maybe just a little louder. Okay. Cool. I'm happy with that. Alrighty. For the events A, B, and C, find the Venn diagram that results in the following. Did I want to start with this one? Not really, but I'll start with this one, I guess. Let's start with question 1A. Find the Venn diagram that results in the following. At least one of the events A, B, or C occurs. Fuck. This isn't helpful. I don't remember, if I'm honest. Statistics is my least favorite math. At least one of them occurs. We can't just do the area of it. They can intertwine. Not sure how to do this, actually. Because I know you could use the areas and everything like that to solve for it. That should be good. Yeah, I'm actually confused. How do you find this? Events A, B, C, find Venn diagram that results in the following. Find the Venn diagram. What is it asking for? Does it want me to make a Venn diagram? Oh. So am I making the sample space? Find the Venn diagram that results in the following. At least one of the events occurs. So I think I'm just making it, making the sample space so that one of them occurs. I'm assuming that's it, right? Yeah, that's gotta be it, right? Yeah. So we'll start with our sample space. S. We'll set this to be A, B, and C. Yeah, it's kind of like not proportional, but C, A, B. And I feel like that's right. Yeah, I mean, I don't really know how else I could do that. Should I do it, or should I make it neater? I'll make it neater. So we'll start with S here. S, A, B, C. Sure, whatever. And I guess like maybe shade in the areas that is being done. C. All three events occurs. Oh, maybe I'm just shading in. I mean, I don't really know how else I'm supposed to be doing this. I feel like this makes the most sense, yeah? Almost one. Okay, so for C, for all three of them, I mean, I guess we will create the Venn diagram, maybe? And something like that. And write down A, B, and C. Just make sure that is clearly shaded in. So, like, maybe do a darker even. D. Only one of them occurs. So yeah, I guess for D we would draw in our sample space again. And only one of them occurs, so we don't want any of them touching. Oops. I don't really want that to be C. Try to keep it somewhat consistent. And then D. Events A and B occur, but not C. So we will draw in our sample space again. I mean, I guess I'll shade those in too. Let me actually do it bigger, because I want them to be a Venn diagram still. A, B, and make sure that's known as S. We'll have this be C on the outside, not included. And I feel like that's a valid response, yeah? Sure, why not? Fuck, I'm out of lead on this. Nice. Okay. Come on. Am I out? Okay, there. Dos. It's again letters. notes I can look at. Let's see, which notebook was it? Black notebook is not for this class. Yellow one's for coding. So it's not blue either. Holy shit, is it this one? Did I fuck up? No. So I just happened to miss the one notebook for this class. Nice. Yep, there it is. So somewhere in the beginning here, I have a union and intersection. Where is that at? Union, okay. Unions A or B or both. Intersection is only the two in common. Or however much in common. Okay. That's what I thought. Just wanted to verify. Okay. With that knowledge, we can know that for AB union, so just combine them all. A union B will be equal to 1, 2, 3, 4, 5, 6, 7, 8, and 9. B, we have A intersect B, which would be the two they actually have, the amount they have in common, which is 3, 4, 5, and 6. 3, 5, 6. C, what do we have? C is A intersect B complement. So basically anything that's not in B, anything that's not in B that is in A. So 1 and 2. Right? Yeah. Yeah. A intersect B complement is equal to just 1 and 2. Because those are the only two that's not in B, but that is in A. And then for D, we have A complement intersect B complement, which that would be some that numbers that aren't in either one of them. So 10, 11, 12. 10, 11, and 12. Because 0 is not included, correct? Correct. E. It's a bit more complicated. I'll write it out. We have A intersect B, all complemented, which is equal to, using the De Morgan's law, we have A complement union B complement, which that would be equal to, what is that equal to? What's not in A plus what's not in B. What's not in A is 7, 8, 9, 10, 11, 12. 7, 8, 9, 10, 11, 12, and what's not in B is 1 and 2. That's not included. Okay. 1, 2, 7, 8, 9, 10, 11, 12. Use axioms of probability and set the operations to prove. Fuck. I don't know how to do that one actually. Is it in my notes somewhere? We have this in our notes. that's assuming that it is, what's it called? Collectively exhaustive. So it takes up the entire space. Is it mutually and collectively? I don't know. Just trying to prove this is a bit more annoying just because I'm trying to think of how you could do this. Because, like, logically thinking about it, it makes sense. Like, probability of A union B, so A and B. Probability of A and the probability of B minus whatever is intersected between these two. So we don't count it twice. Fuck. The fuck prove it, though? Because, like, we have it right here. But I don't... In class, it probably explained it, but... I'm just trying to think of... I don't even know what the axioms of probability is. How do we show that that is equal to probability of A and the probability of B? Maybe I just Google this one. Yeah, I think I'm just gonna Google it because I'm not really sure. Axiom of probability, right? Axiom of probability proof. So based on this image, we have A union B is equal to A union B intersect A. I feel like that's not really helpful. Like, because you can say this right here, which, like, yes, that makes sense. In a way. But how the hell does it really make sense? Not really. Like... Because this part, okay, sure, makes sense. Makes sense how you got here. But if you can just straight up pull out that A, that, all that. I mean, I guess I can just write that down. But I want to try to understand it better before I actually just write it down. We know we can't just add them together because this also could include their intersection. And if it includes their intersection, it doesn't matter. Okay, you can't see it, can you? So we would need to somehow... We can take the A, because this isn't including any of A, we can just put it to the side. We can add it like that, just like how that is. And then... I don't know. Like, this property itself, like, makes sense. So, like, makes sense, so much sense logically already. So trying to prove it is proving to be difficult. So I'm thinking of just writing this down because I understand it. I guess not to a deep enough degree, but I don't know how else you really, because even here they don't really do a whole lot of proof in it, I guess, because they just say, oh yeah, the probability of the unions, you can just add them together if it's not included at all, which, like, I don't know, to me just doesn't make a whole lot of sense, but I'll write that down. Because, like, it makes so much sense, but it's also like, how do you prove you just add those and you can't add that? I don't know. Because to me, it's the same premise. Like, if you can just add it, as long as it's not included, why couldn't you just say you just add it, as long as you don't include what is already combined? I don't know. I'll figure it out. So we have probability A union B is equal to the probability of A union B intersect A complement, which is also equal to probability of A plus probability of B complement A, or B intersect A complement, which is equal to probability of A plus probability of B minus probability of A intersect B. And I mean, technically, I think, yeah, it's written the other way up here, but yeah. Okay, I mean, I guess that's gonna have to be it. And we will go to our next page on here. We are on 4. So we write down 4, oh shucks, consistency, A. You flip a coin 3 times and note the sequences. Assume all sequences are likely. Specify the sample space. So this one's really easy. We're just saying what the sample space is. And you just want to write down every single possibility of combinations that we could get. And using binary laws, you can take it one by one. You could probably just think of H as being zeros and T's being 1. So we have 0, 1, 1 here. And then we can't go up 2, so we have to make this a 1, 0, 0, 1, 0, 1, 1, 1, 0. Oops. 1, 0, and 1, 1, 1, which is 7 in binary. That is the sample space, so that's it. Determine the probability of the below events. 3 heads. I mean, probability of H is equal to 1 out of 8. I mean, I don't really know how to prove that, but I feel like that should be enough because it's simple enough once you like understand it. You're just taking the total number of possibilities it is and how many times it appears in that, and it only appears once, so it's 1 over total number of possibilities, which is 8. So C. Sequence head, tail, head. Same thing. Probability of head, tail, head. There's only one chance of that happening out of 8, so it's just 1 out of 8. D. This one gets a bit more interesting. I know there's like some way you can solve it mathematically, and I probably should learn that, so I will look at my notes for it. Ooh, it might be on my computer notes. No, it's not. Maybe it is. I don't know. But in the end, you're just looking at how many times there's 2 heads and only 1 tail. Probability of 2h comma 1 tail, which is equal to probability of HHT plus probability of HTH. Is there another one? 2 heads, 2 heads, 2 heads plus probability of THH. Yeah, that's all the positions T could be in. Yeah, that is another way you could look at it, huh? Okay. Which is equal to 1 over 8 plus 1 over 8 plus 1 over 8, which is equal to 3 over 8. And now we're on E. Any sequence where the number of heads is greater than or equal to the number of tails. Easier way to do this is just to see which ones has less or more tails. Not equal amounts, or you can't have equal amounts. Is that not what we just did here? The fuck? Any sequence where the number of heads is greater than or equal to number of tails. So wherever we have more heads than tails. And that's exactly what this is. I don't know really how. I feel like there's got to be like an easier way to write this down visually so that you can see like what it's supposed to mean. But it's basically saying the same thing. Because we do an odd number of times, it can't be equal to each other. So it's only when heads is higher, when there's more heads, which is 2 or 3. Or 3 is another possibility. Heads is greater than or equal to tails. So when heads is equal to 2 comma 3, I'll put a number here. So we'll do probability of HHH comma HHT comma HTH comma HTHH, sorry. THH, which is equal to 4 out of 8, which is equal to 1 out of 2. Yeah, because really, when you're flipping it 3 times, you're basically just asking, what are the chances you get more heads than tails? 50-50. Which makes sense, logically. Okay, we're on 5. This is another question one, but these letters are capitalized. Okay. I have class in a little over an hour now, so I got some time. My hope for right now, before I go to class, is to probably finish these homework assignments. At least this one. I might have to work on the other one after class today. Alice and Bob choose at random a number in the interval 1, 2. We assume a uniform probability law under which the probability of an event is proportional to its area. Okay. So basically the area is the probability. Proportional, sorry. Because that does matter. Yeah. If it was 0 to 1, then it would be the area, but whatever. Consider the following events. Magnitude. We're just looking for the probability. Oh, okay. I see what we're doing here. Yeah, there we go. Probability of A by itself is equal to magnitude of the difference is greater than 1/3. So there's at least let me write it down like a number line. 0 to 2. Yeah, because how the fuck do you calculate the area of that? Because it's just a number line. Right? I don't know. I guess I see how. Oh fuck, I just had an idea. X, Y, let's say Alice is X, Bob is Y. Why not? So let's do that. That. 2, 2, 1, 1. Bob. What are the chances that can be here, but it could be like here-ish? And if they pick like something close to 0, they only need to pick something like that. I'm trying to figure out like the scope of this, what this could be. Something like that, I feel like, I don't know. Like anything up here or anything down there. I feel like that makes sense, doesn't it? I know for a fact we talked about this in class. I don't know if I don't think I've written this one down. I think all of that was on the computer. Yeah, because this was what we talked about yesterday. Yesterday was Sunday. So Friday. Same here. And then this is stuff I gotta put down in my notebook here. I thought I would have put it in, not in my thing, but I guess not, because it's like graph. Fuck. I'm trying to think of how I can do this then. is proportional to this area. So basically, I just need to figure out the possible. I mean, technically, all numbers are possible, isn't it? They can both pick any number, really. So I don't really. That's not really a valid response. I guess we can think of if Alice were to pick a number, what could Billy pick? Billy could pick theoretically any number. If Alex could pick any number, that's not helpful at all. I don't know how to do this. How do you do this? Jiminy Cricket. Yeah, I'll guess I'll have to look my notes on the laptop. Oh well. And I don't even think this is gonna help me if I'm honest, but it's worth a shot. Let's see what we have typed up here. Google Docs. Let's see. This is ECU 280. Probability of A given B occurred. Way to find probability, put the event in the sample space, take the area of event divided by area of sample size. That's the thing. Because it really depends on what the other person picked, because all numbers are possible. Because I mean, like, I understand take the area or find the area and everything like that, but I need to figure out how to make the graph, to make the area. It's definitely not just that what I was originally thinking, but that's definitely not it. Because whenever B is 0, we can have any of these numbers here. And whenever A is 0, we can have any of those numbers here. Let's say B was 1. A could be not half. It could be it's like 2/3. 2/3. I said I was speaking X, but I swapped it around. That's fine though. 1, 2/3. And same thing with Alice. If Alice picked 1, that can be 2/3. 1, 2/3. Let's say they picked 1/3. If they picked 1/3, the other person could pick 0 or any 2/3 and up. That's just so. I don't know how the hell you do that. I don't. Is there a video I can watch maybe? Because I really don't understand how I could do that. is the question. Find magnitude of the difference of the two numbers is greater than 1 divided by 3. I don't know if I still have my chat connected here. Let's see. So I found this one, and it tells you this. Like, it gives you this, which is slightly different, because maybe C will tell us how to find A. Because with B, I feel like I could find that one. Because for B, at least one of them is greater than 1/3. So at least this one or this one. Sorry, not that, but the opposite inverse. So one of these. That would be for that B. I think we would subtract the combination. No, because it doesn't matter if it's both of them. But it doesn't, we don't want it, right? I don't know. Let me think about this real quick. Because do I have that same question on here? At least one of them, yeah. So for B, at least one of them is greater than 1/3. I'm pretty sure this is how you would start it. You have this, the area of those two, minus the union of those. So it only counts it once. So what is that? 1/3 minus 2 minus 1/3 multiplied by 2. And then, I mean, sure. I think we could just do it like that. I don't see why not. It's probably not the right way to do it, but as long as it gets me the answer, it should be fine. I think we'll start to worry about it if there is something that blocks us and not let us solve it that way, such as A. Probability that the two numbers are equal, 0, basically. If we're including all real numbers, it can be infinite number of decimals, so that's just 0. Alex's number is greater than 1/3. Alice's specifically. So yeah, I feel like those ones are easier. Right now, I'm just struggling to figure out how you would find probability of A. So let's see if we have. Let's give a quick glance to see how right we are. Can we zoom in a little bit, maybe? That's a little not right. Not what I wanted. It's better. I don't know if that's what it was, but oh well. Alice and Bob. What number is that? Yeah, they just took the integral, which is like a simpler way to do it. You're just finding the area, so yeah. 1/2. Maybe that's a 3. Definitely not a 3. Yeah. They just use a calculus to find it, which is fair. That's the simplest way to do it. But I'm gonna solve it using my own method still. So this is, yeah, this is exactly what I was thinking. But I don't feel like that's right. There's no thumbs up or thumbs down. Oh yeah, I guess come up with a formula for that. Yeah. X equals 1/3 plus y. Yeah. And we just added them together, right? Blah blah blah. No region. And then finding the areas for those two. And then for that, we just take a shaded area, both of them, divided by the total area, which is, yeah, just 2 times 2. Yeah. So, I mean, yeah, that's valid. Okay. So, use that formula. Make a formula out of it. That one of them minus the other is equal to 1/3. That's what we're looking for. Okay. That's simple enough, yeah. We will erase all of this. Did I exit it out? No. Because I'm just curious as to. I mean, I guess you don't really need to. Yeah. Yeah. I mean, I guess I didn't think about it like that. It can be anything, but if they were to pick one, if like B were to like pick 1/3, you have to like go up here to in that line. If B were to pick 2, you have to go way over here, or maybe not that far, but like it's still like no matter what in this line somewhere. That has to be the case to actually make it valid. Okay. Okay. So let's say we have our A minus B is equal to 1/3. B minus A is equal to 1/3. B is equal to 1/3 plus B. B is equal to 1/3 plus A. So we start at 1/3 over 3. 1/3. And it's linear. So we can legit just say what happens when it's 2 for both of them, and it would be the same number. So let's say if B was 2, that'd be 2/3. Not 2/3. 2 2 1/3. That's high. Oh, that's like up here. But it, maybe we gotta do that down here. If A was 2, yeah, let's do like that. If A was 2, B would have to be, look at it down here. No, that's not the same thing. If A was 2, B would have to be 5/3. 5/3, which is equal to 1 2/3. And it's the same thing down here. 5/3, comma 1 2/3. Same idea for both of them. And we just find the height of that, which is, let me get a calculator. Calculator. Maybe. Let me try something here. I want like maybe game capture, create new calculator. Okay, and specific window. Can we find Chrome in this? Doesn't look like it, no. Which is fair. What if we first cancel that and we open up the calculator app on Windows? See there? We try to add that on here. How do I know what we just tried? Yeah, whatever. Game capture, calculator. And specific window, and we can do the calculator now. We don't want any of the audio. We don't need to capture the cursor. Okay, sure. It's not showing up, actually. Which is not what I wanted. I might just have to say forget it and maybe figure out later or something. Calculator is not being captured, which is fine. It's just a bit annoying. Even if we were to try to do it again, yeah, I doubt it'll do anything. Let's just name it that temporarily. Specific window. don't think we're gonna get anything from it. Okay, yeah, that's fine then. We'll just have to deal with not being able to see the calculator. Sorry. Yeah, I don't need this, do I? No. No. I can just exit that out. We're still working on number 5 here. What was the math I was trying to do even? Fuck. 2 minus... maybe we should do clear. 1 divided by 3... 1 divided by 3 is equal to... minus 2 is equal to... dude, I knew what that was. I don't know why. Whatever. So 1 2/3, that's what that is. The area, like from this to this, that's 1 2/3. Same thing here, from 1, that's 1 2/3. And that's going to be the same thing down here. So we have 5 over 3 times 5 over 3 times 1 over 2. We don't even have to do 1 over 2, do we? We can just... because we're adding them together anyways. That'll just kind of cancel that out. So 5 divided by 3 squared. I don't think that's right. I don't know. 5 divided by 3 times 5 divided by 3. Let me pull that back up, actually. Go back over here, history. Just because I want to see what they got, just to make sure I understand it right and I'm doing it correctly. So from what I get, it should be like 25 over 9. That's not a valid probability, though. Oh, yeah. We divide it by the total area of the stuff. 5 divided by 3 times 5 divided by 3 all over 2 times 2, which is equal to 25 over 9 all over 4, which is equal to 25 divided by 9 times 4 is equal to 9 times 4, 36. 25 over 36. And what did they get on here? Not what I got, huh? Is it different for the top and bottom? I didn't think so. I thought it would be just the same. What the heck? Area of region 1. Because... are their regions different, maybe? No? Interval 0 to 2. For both of them. I don't think theirs is right. Either that or I'm just not understanding how you're supposed to do it. For the area of region 1, 2 minus 1 over 3, which is fine. And then 5 over 3 minus 0, which is fine. And then 1 divided by 2, which is fine. And then how is the second region not the same? What? 5 5/3. Maybe I was too quick to just assume that it was the same. Nope, that's the same. That's 5/3, and that's 5/3 here. 0 to 5/3. Yeah, that's still the same. Which makes sense logically because you have an equal. They have an equal amount of chance of picking some random numbers. It shouldn't be different. You shouldn't have a lower chance. Let's pick one or the other. So yeah, I don't think theirs is right. And yes, I did not multiply it by 1/2, but I don't need to because I would have added those together anyways in the end. And when you're adding the same things together already, it would just be multiplied by 2. So yeah. I mean, logically, I feel like that makes sense what I have. And I feel like they're just wrong. Are there any comments? No. Yeah, I'm just gonna do what I have, what I got for it, just because I feel like that makes the most sense. Because I do. Yeah, I'll just leave it at that. Because I feel like in the end, if you get a number less than 1, let's say it's right. Why not? B, probability of B happening, which is a bit simpler, a bit more simple, because all we're doing is seeing if one of those are greater than 1/3. So we're taking that and finding the area of all of that. So basically, all we really need to do is find the area of the whole thing, subtracted by the area of the part that's not included. I'll write that down even. Area S minus I won't write that down because there's not really a great way to write it down. Not yeah, because like you're taking the area of the whole sample space minus the area of the. I mean, yeah. Area of the sample space minus area of what's not included between those two. Yeah, no, I'm not gonna bother with that. Explaining my math here, because I don't think it really matters. I'm checking the area, and I feel like as long as I write down the areas, it'll be okay. So we'll take 2 times 2. We also need to divide it by the entire area. So we have 2 times 2. We have 2 times 2 minus 1/3 times 1/3. Yeah, I feel like that makes no sense to me. It's just a square for both of them, yeah. So we'll get our calculator out again. And, I mean, there's not really much math we need to do immediately, so. At least not with the calculator. 4 minus 1/9. 1 divided by 9. 4 minus... Oh. divided by 9 minus 4. That's positive. Yeah, I don't even know why I'm so dumb. There's no point in using a calculator. Just convert it to a fraction. What the hell? 4 times 9 is equal to 36. 6 over 9 minus 1 over 9 all over 4, which is equal to 35 over 9 over 4, which is equal to 'You're just multiplying 9 and 4, right? 9 times 4, which is equal to 36. 35 over 36. And what did they get? I exited out again. Damn. What did they get? What did they get? Oh, hold on. Yeah, I gotta reset it, refresh it. Got signed out because I can never just stay signed in for this anymore. I don't know why, but that was the first one they had, and yeah, 35 over 36, that's what they got. Good. And the probability of C, I believe we're looking at now. Yes. Probability of C, it's just 0. I don't know how to prove it, but let me just check to see if they have that written down somewhere. Yeah. They have it written down and they kind of like explain why it's 0 and everything, but I feel like I don't really need to explain it because it's just 0. The chances of having two of the exact same numbers is near 0. It's basically 0. Infinitesimally 0. Now, in the real world, if it was actually two people, there is a chance that they both pick the same number. Still very unlikely, but it's not infinitesimally small, the chances of that happening. Unless you're just trying to be funny. Probability of A intersecting D. So basically, the same premise as before, where they intersect with each other. I won't exit that out this time. So where they both have in common, what they both have in common. And Alice's number is greater than 1/3. But yeah, if B were to pick this Alice would have to be up here. But yeah, and we are looking at the probability of Alice here specifically having anything greater than 1/3 and is within that. So really, it's everything. It's just the area of that, isn't it? So it'll just be this 5 over 3 times 5 over 3 times 5 over 3 times half times, or divided by 4, right? I feel like that makes the most sense. Is that what they have here? Is that what they even ask on here? Yeah, that's the very last one. Oh, that's where they got that from. Okay. That's why their answer was slightly different because their answer wasn't the same answer that I was looking for before. So I think I'm actually right with that then. Good. Let me do some quick maths, I guess. Region 2. Why do these two different regions matter? Okay. Because we need to find a number where Alice only picks something 1/3 or greater. They had their Alice and Bob swapped, didn't they? That's why it's slightly different. So this one's going to be smaller. Because if Alice only picks 1/3, Bob could have 0, which is just infinitesimally small. Or it can have anything else. Not 1/3, but 2/3. Alice can pick 2. If Alice picks 2, it's the same thing up here. So yeah, I think that's still valid. And we have to pick numbers that are the same. So that's where I'm like confused exactly. I mean, I guess it makes sense. Only where, because Bob can pick anything over here, and Alice would pick these same numbers. But if Alice, because this is still 1/3, but if Bob were to pick, or if if Alice is only picking numbers greater than 1/3, Bob's answers are technically 0 as well, but that's infinitesimally small, so you don't really even need to count it. Plus, from 2/3 all the way up to the same number, because it's still, if it's 2, it's still up there. If Alice picks, I mean, it's technically probably more like up here or something, but I don't know. Alice were to pick 2, Bob would have to pick something like over here or something. But yeah, it's not 1-to-1, so I shouldn't look at it too much like that. But I think logically it makes sense, though. It would still have to be 5/3 if Alice picks 2, because he can only pick up to 2. So yeah, we take that and we do 1/2 times 5. Do it better. Times 5/3 times 5/3 plus 1/2 times. Wait, why did I do 5/3 twice? Because that is the size of that here and that one. But for this one, it's 1/3 smaller even. Bob doesn't have as many options. So we would have to pick 4/3. 4/3 times 5/3 still. All divided by 4. So let's see how close we can get to this. 25/18 plus 20/18 all over 4, which is equal to 45/18 times 4, which is equal to, what is 18 times 4? 72. 45/72. And is that what they got? No, they got 41. So theirs is slightly different. That is because they didn't get 6. I didn't get 16. I got 20, and that is where my issue lies. So for some reason they got 4/3 still, going up, but I don't think that's true. Oops, damn, that's fucked up now, huh? There, that's better. 5/3, 5/3, yeah, blah blah blah. Region 2. This is the one I'm more interested in. I wish I can zoom in better. I mean, I can, but you guys won't be able to see it as well. We'll just leave it at that. It'll be okay. Where are we? Down here. So you have half 5/3 minus 1/3, which is what I had, times 2 minus 2/3. Why is it 2/3? Why not 5/3 still? Yeah, I feel like that's not right. Because this is their 1/3 x value and 2/3 here. Yeah, I don't know. I know my way isn't much better with visually seeing it, but I feel like theirs is wrong still. But I want to verify before I just say that's fine. Because 5/3 equals 4/3, I got that far. Like with this here, that's 4/3. That's fine. But up here, it's not like this is getting shorter or anything. If Alice can pick 2, and you can still have 5/3 for your answer for B. It doesn't change anything. That is the max B can be. And that's pretty much all you're doing. Taking what the minimum can be times what the max can be, and then multiplying by half. Well, not minimum. The maximum size. Maximum size here. So this maximum size is only 1/3 less because it has to be. But for this one, because Alice can pick 1/3, and technically you're including 0, but that doesn't really matter because it's 0. It's a specific point, and when it has a specific point, the probability is basically 0. So that doesn't really matter. When it's 2/3, or when it's 1/3, you pretty much only can have 2/3 or greater, basically. 2/3 or greater, which makes sense. But if it's 2, you can still have 5/3. 0 to 5/3 is that height still. Because it's not like you can still pick. You can't pick A equals 2. Can you, actually? Or A equals 0. So that doesn't matter, does it? Because if you were to pick A equals 0, that's not valid. So A has to be 1/3. Which, okay, I think that's starting to make more sense now where that extra third is coming from. Because if A is 0, before you were thinking, no. Because that's not how that was thinking. It's, if A was 0, this can be 2/3. Or this can be 1/3 still. But A can't be it. A has to be 1/3, so that has to be 2/3. But if if A went all the way up to 2, B can still be 0. B can still be way down here. Or it can be way up here at 5/3. I didn't know this was classical music. Interesting. But yeah, I'm trying to like think of their logic with that and why theirs is right. I don't think it is though. I really don't. Because I'm trying to figure out why it would be 2/3, but it could be 5/3 up here. Because we're still assuming that they're like 1/3 separate. So yeah, I'm just going to go with my answer, 45/72. Because I don't see why they took off another third, whatever here. Because logically, when I think about it, it doesn't make sense. So. Yeah, we'll leave it at that. It's 2:06. My class starts at 3. So I'm gonna have to get going pretty soon actually. Number 5 took a bit longer than I was expecting. I think I can maybe do 6 real quick here. Pick 2 numbers, x and y, such that x squared plus y squared is equal to 1. Okay, so sure. Determine and draw that sample space. So we're basically just making a unit circle with this. Right? Yeah, it's just a unit circle filled in. That's literally what it is. Something like that. And it doesn't have to be perfect, I know that. Yeah. Yeah, it's just a unit circle though. Yeah, if you pick -1 for one of them, the other one will still be 0 and it'll still be valid. If you pick, yeah. What is the probability that x is greater than 0 and let's draw that again. Same shitty unit circle drawing. Probability that x is greater than 0, so anything over here, and y is greater than 1/2. So it can be anything within that cross section. And we'll need to find the area of that. I don't know how to find the area of a chord like that. I don't. I really don't. I don't know how you would start that one either. Fuck, I hate that. The fact that I don't know how to do this. I'm gonna have to stop going though and just go to class because I don't have much more I can do with this right now, at least. I don't know. I know there's got to be a way to calculate that. I'm not good with areas and shit. Geometry's my least favorite. Probably actually statistics my least favorite. Second least favorite geometry. So just combining my least favorites. Yeah. I will probably take a small break from this after class and do my other homework here. This bit here. Which I feel like would be fine. I got a good chunk of this done already. Over halfway done. So, yeah, I'll leave it at that for now. I will be back later to finish out this homework, I believe.